Dear students, do you want to get into the fascinating world of physics? Please see this video and also subscribe to this channel.
Dear students, in this video let us learn about phasor and phasor diagrams. Now let us study about phasor and phasor diagram. What is a phasor? A sinusoidal alternating voltage or current can be represented by a vector which rotates about the origin in anti-clockwise direction at a constant angular velocity omega. Such a rotating vector is called a phasor. A phasor is drawn in such a way that the length of the line segment equals the peak value Vm or Im of the alternating voltage or current. Its angular velocity omega is equal to the angular frequency of the alternating voltage or current. The projection of phasor on any vertical axis gives the instantaneous value of the alternating voltage or current. And the angle between the phasor and the axis of reference, which is a positive x-axis, indicates the phase of the alternating voltage or current. What is the importance or the notion of phasors? The notion of phasors is introduced to analyze phase relationship between voltage and current in different AC circuits. Now let us study about this phasor diagram. What is a phasor diagram? The diagram which shows various phasors in their phase relations is called phasor diagram. For this, let us consider a sinusoidal alternating voltage V given by Vm sin omega t applied to a circuit. This voltage can be represented by a phasor, namely OA segment, that is here OA, which is as shown in this figure. Here the length of OA equals the peak value, that is Vm, that is maximum voltage. The angle it makes with x-axis gives the phase omega t of the applied voltage, and its projection on y-axis provides the instantaneous value Vm sin omega t at that instant. When this OA segment rotates about O with angular velocity omega in anticlockwise direction, the waveform of the voltage is generated. For one full rotation of OA, one cycle of voltage is produced. The alternating current in the same circuit may be given by the relation I equal to Im sin omega t plus phi, and that is represented by another phasor OB here. So here it is the Im sin omega t plus phi is the instantaneous value of current I, and in this case the phi is the phase angle between voltage and current, and the current leads the voltage by a phase angle phi, and that is shown in this 4.39. Here the current will be leading the voltage, and if the current lags behind the voltage, then we can write the expression as I equal to Im sin omega t minus phi.